All right, Mr. Ahmed here for 3.5. Goal for today is to work with the equations of parallel and perpendicular lines. What we're going to do today is we're just going to really look at some lines and identify whether they're parallel or perpendicular in the coordinate plane. And we'll also calculate some slopes. We aren't actually going to write the equations of lines. You guys did that last year, so we're going to kind of just stick to identifying whether they're parallel, perpendicular, etc. So the first thing we want to discuss is slope. The slope is the steepness of a line. When I have 2 points in the coordinate plane, x1, y1, and the other point, x2, y2, we calculate the slope using this formula. We find the change in y over the change in x, which is the rise over the run. Positive slope goes uphill from left to right. Negative slope goes downhill from left to right. The slope of a horizontal line is 0, so that'd be 0 divided by a number. And the slope of a vertical line is undefined. That's when we divide by 0. If 0's in the denominator, that's undefined. Can't do it. So we're going to hop into our first example here and find the slope of a line. And I'm given 2 points. I labeled the first one x1, y1. I also could have labeled this one x1, y1. The choice is yours. But the other one needs to be x2, y2. Now to calculate the slope, we plug these values into the formula. So m is the variable for slope. That's equal to y2 minus y1, so 7 minus 3, over negative 5 minus 2. And when I calculate that, 7 minus 3 is 4. Negative 5 minus 2 is negative 7. So the slope of this line is 4 over negative 7, so that's a negative slope. It would be going downhill, so it goes down 4, right 7, down 4, right 7. All right, hopefully that's a good little review from last year. The slopes of parallel lines. Parallel lines have equal slope. They have the same slope. Any two vertical lines would be parallel. And in the same manner, any two horizontal lines are also parallel. And that really wasn't included in this definition because 0 is equal to 0. So those two slopes are equal. But we really need to indicate that the vertical lines are parallel as well because they're undefined. So any two vertical lines are also parallel, which kind of makes sense. As we kind of look at this graph here, in order for these lines to never touch, they would have to be going at the same rate. Okay. The next thing we're going to look at is some equations of lines. For us to identify the slope of an equation of a line, we need to put it in slope-intercept form, which is y equals mx plus b. So y needs to be isolated. Once y is isolated, we identify the slope, m, as the coefficient of x. So the number that's next to the x, that's going to be the slope. And just a brief little recollection, this is the y-intercept. So when I look at this line, y is already isolated. If it's not, I would have to isolate y before I say what the slope is. So it needs to say y equals. Y must be isolated. And in this manner, y equals 4x plus 6, or plus 7. The slope is 4, the coefficient of x. Okay, so we're going to have to identify the slopes of lines given an equation as well. When we talk about perpendicular lines, the slopes of perpendicular lines, they intersect at a right angle. Okay, perpendicular means two lines that intersect at a right angle. Really what we have going on is the product of their slopes is -1. More commonly, we refer to that as the slopes are opposite reciprocals. So an example of an opposite reciprocal would be 1/2 and -2 over 1. Keep in mind, -2 over 1 is just -2. So these are opposite reciprocals. They're opposite signs. One's positive, the other's negative, and they are reciprocals. If I multiply these two numbers together, I would end up with -1. Horizontal lines are also perpendicular to vertical lines, okay? And really, we're just going to calculate the slope of one line, and then I'm going to come up with a couple more examples here. So it says find the slope of the line that passes through the points 1, 2, and 9, 7, and then find the slope of the line that's perpendicular to that. So I got to do 2 steps. First, I need to calculate the slope of this one. x1, y1, x2, y2. M of line 1, I'm calling that line 1, is equal to y2 minus y1, 7 minus 2, over 9 minus 1. is equal to 5 over 8. So the slope of this line is 5 over 8. So the slope of the line that is perpendicular to it is the opposite reciprocal. So 8 over 5, and this one's positive, so ours new one needs to be negative 8 over 5. Okay? So, as we're kind of working through our assignments, you're going to have to put these things together in order to determine whether the lines are parallel or perpendicular or neither. Or neither. So if they're neither, that just means they're intersecting. So I'm going to pick the first one as y equals 2x minus 8. And then our other line is going to be, let's go with 2y plus x equals 7. Okay? So when I take a look at this first line, the slope of the first line, I need to identify what it is. The slope of this one is 2. Now, for the bottom one, I can't identify the slope of this line until I isolate y. I need to put it in slope-intercept form. So for me to isolate the y, I'm going to subtract x from both sides, and I get 2y equals negative x plus 7. Next step is to divide both sides by 2, and y is equal to negative 1 over 2. I have to divide this. Negative 1 over 2x plus 7 over 2. So the slope of this line is negative 1/2. So when I look at these two slopes, I have the slope positive 2, which is 2 over 1, and I have negative 1/2. Those are opposite reciprocals, so the lines are perpendicular. And you might also have to use the slope formula for some points to identify these, but really that's what we're going to be looking at for this assignment. Hopefully you have a good rest of the day. Talk to you later.